Alright, space explorers. Let's talk about something we all dream of. Venturing out into the cosmos, planting a flag on a new world, becoming a legend of space travel. We see it in movies all the time, right? Astronauts hopping around on distant planets making incredible discoveries. But here's the thing the movies don't usually show you in graphic detail. Our solar system is basically a cosmic minefield filled with planets that are actively and very creatively trying to kill you. It's less like a scenic vacation and more like a 9-level video game where every boss fight is impossible. So today we're going on a little thought experiment. We're going to take a journey through our celestial neighborhood, but instead of packing for a holiday, we're packing for our immediate, scientifically accurate demise. We're going to ask the question, what would really happen if you, a squishy human, tried to set foot on each of these planets? For example, if you landed on Venus, that beautiful glowing planet wouldn't just be hot, it would crush you like an empty soda can in a hydraulic press before you could even say ouch. It's a level of inhospitable that is honestly kind of impressive. From a purely scientific standpoint, this isn't just about fear-mongering. This is about appreciating the insane, mind-boggling physics and chemistry at play across our solar system. We're going to do a full science breakdown from Venus all the way out to the icy plains of Pluto, exploring the specific, gruesome ways each planet would end your adventure. We'll look at atmospheric pressures, radical temperatures, toxic gases, and the sheer violence of these alien worlds. Think of me as your slightly morbid but very enthusiastic tour guide to the galaxy's most deadly destinations. It's a cosmic horror story, but with lots of cool science. So buckle up, because this is your official, one-way ticket to understanding planetary science in the most visceral way possible. We're going to peel back the curtain of serene beauty that we see through our telescopes and expose the chaotic, deadly reality lurking just beneath the clouds. By the end of this, you'll have a whole new appreciation for our cozy little blue marble Earth, and you'll understand exactly why we send robots to do this kind of work. Our tour starts with the hottest, most hellish planet right next door. First stop, Venus. Okay, let's imagine you've just won the unluckiest lottery in the universe, and your mission is to land on Venus. As your capsule descends, you'd first notice the thick, yellowish clouds of sulfuric acid. Not a great start. But the real fun begins the moment you step outside. Instantly, you would feel a force unlike anything on Earth. The atmospheric pressure on Venus is over 90 times that of our home planet. That's the equivalent of being nearly a full kilometer, or about 3,000 feet, deep in the ocean. Your state-of-the-art, multi-billion-dollar spacesuit, designed for the vacuum of space, would be completely useless here. Before you could even process the crushing weight, you'd hear the terrifying groan and shriek of metal and advanced polymers giving way. Your suit wouldn't just leak, it would violently and catastrophically implode. It would crumple inwards, like you were a piece of paper being balled up by a giant invisible hand. Every single structural component would fail simultaneously, driving shards of your helmet, visor, and life support system directly into you. The sheer force would be so immense and so instantaneous that your final moments would be a chaotic symphony of snapping bones and collapsing technology. With your suit gone, the full 1,300 pounds per square inch of pressure would hit your body. Your skeleton, which is miraculously strong but not that strong, would be the next thing to go. Your ribs would shatter and collapse inward, puncturing your lungs and heart. Your limbs would be twisted and broken as the pressure found no resistance. In less than a second, your human form would be compressed into a horrifying, unrecognizable shape. You would literally be pancaked onto the Venusian surface, a flattened testament to the unforgiving laws of physics. It's a brutal mechanical end delivered by an entire planet's atmosphere, and this all happens before you even have a chance to think about the other ways Venus is trying to kill you. We're talking about a sequence of events that lasts less time than it takes to blink. The pressure alone is a death sentence so swift and so absolute that it makes all other threats seem secondary. You wouldn't die from the heat or the toxic air, because you'd already be a human jelly packet smeared across the ground. But for the sake of science, let's pretend for a microsecond you somehow survived the crush. Well, Venus has plenty more horrors in store for you. So let's engage our science fiction imaginations and say you have an imaginary, uncrushable suit. You've survived the pressure, congratulations. Now you get to experience the heat. The surface temperature on Venus is a blistering 465 degrees Celsius, or about 870 degrees Fahrenheit. That's hot enough to melt lead. and it's hotter than the inside of a pizza oven cranked to its maximum setting. Your body, which is mostly water, would react in a terrifyingly predictable way. The moisture in your skin, your eyes, and your mouth would flash boil instantly. The water inside your cells, the very liquid that keeps you alive, would begin to boil from the inside out. Your blood, superheated in your veins, would turn to steam, causing your blood vessels to rupture all over your body. Your organs would literally cook inside of you. Your brain would be poached inside your skull. It's a level of heat that the human body is simply not equipped to comprehend, let alone survive. You would be flash-cooked in your uncrushable suit, a macabre human stew served up on the surface of our sister planet. This is nature's most extreme barbecue, and you are the main course. And while you're being simultaneously crushed and cooked, let's not forget about the air itself, or the lack of breathable air. The Venusian atmosphere is about 96.5% carbon dioxide, a toxic, suffocating gas for humans. Even if you could take a breath without your lungs boiling, the CO2 would kill you in minutes. It would flood your system, preventing oxygen from reaching your brain and leading to rapid asphyxiation. The remaining percentage of the atmosphere is mostly nitrogen, with traces of other lovely chemicals, including sulfur dioxide and, as we mentioned, clouds of sulfuric acid. So let's recap your first 2 seconds on Venus. You've been crushed into a pancake, cooked from the inside out, and suffocated by a toxic gas mixture. It's a trifecta of planetary doom. There is absolutely no scenario where a human being survives on the surface of Venus for more than a heartbeat. It is, without a doubt, one of the most inhospitable places in the entire solar system. Its beauty in our night sky is a complete deception, hiding a hellscape that is more violent and deadly than we can truly fathom. Alright, so Venus was a bust. Let's try our luck on Mercury, the small, speedy planet closest to the Sun. No crushing atmosphere like Venus, so maybe you survive? Not quite. Mercury's extremes decide your fate. Let's start with the fun side, the side facing the Sun. Here, you get to experience the full, unfiltered fury of our star. With virtually no atmosphere, radiation bombards the surface relentlessly. Standing on the sun-facing side would expose you to radiation levels far beyond Earth orbit. This intense radiation would begin to shred your DNA and give fatal radiation sickness in mere moments. Your suit might offer some protection, but it wouldn't be enough to stop the high-energy particles. You'd feel a burning sensation as the very building blocks of your life are ripped apart. At the same time, you'd be dealing with the heat. Dayside temperatures can reach 430 degrees Celsius or 800 degrees Fahrenheit. That's hot enough to melt lead. Your spacesuit's cooling system would be completely overwhelmed. The ground would heat the soles of your boots to their melting point. The radiant heat from the ground and sun would turn your suit into a convection oven. You would slowly bake, skin blistering, and body temperature skyrocketing. So your final moments on Mercury's dayside would be a torturous combination of being irradiated to death, cooked alive. Your cells would be breaking down from radiation while your bodily fluids boiled. It's like standing next to a nuclear reactor during a meltdown while also being in an industrial furnace. But what if you were clever? What if you landed on the night side, away from the sun? That seems smarter, right? Mercury's lack of atmosphere creates another, equally deadly problem. With no atmospheric blanket, the night side radiates its warmth away, plunging to 180 degrees C, or 290 degrees. This is a cold far beyond anything on Earth. The moment you step onto this frozen landscape, cold starts seeping through your suit. Your suit's heaters would be fighting a losing battle. You'd first feel an intense, painful stinging that quickly gives way to numbness as frostbite sets in. Moisture from your breath would freeze instantly on the inside of your helmet, obscuring vision. Your fingers and toes, the first to lose circulation, would freeze solid. As the cold penetrates deeper, severe hypothermia sets in. Core temperature plummets, shivering stops as muscles fail. Heart rate and breathing slow, cognition collapses, blood thickens into sludge, eventually the heart stops. You become a frozen statue on Mercury's dark plains. Mercury rotates so slowly, one day-night cycle is 176 Earth days. You can't just wait for morning. The Terminator, the Twilight Zone, sweeps temps from plus 800 degree F to 290 degree F. Rapid swings cause massive thermal stress on your suit. The suit likely cracks and fails, exposing you to vacuum while burned and frozen. Mercury gives you options, but they all end the same way. Alright, next up on our tour of planetary death traps, vertical bar is the one you've all been waiting for. Mars. Vertical bar, the red planet. Vertical bar, the one we're actually trying to get to. Vertical bar. It seems almost hospitable, right? Vertical bar, like Earth's slightly rustier, colder cousin. Vertical bar. You see those stunning images from the rovers. Vertical bar, the sweeping dusty plains, vertical bar, and majestic silent mountains, vertical bar, and you think, hey, I could probably hang out there for a bit. Vertical bar. But that's the ultimate cosmic catfish, my friends. Vertical bar Mars lures you in with this false sense of security. This deceptive calm vertical bar before it reminds you in the most brutal way possible that you are very, very far from home and ridiculously out of your element. Vertical bar. It's not the instant fiery death of Venus, vertical bar, but a more insidious creeping demise. Vertical bar. The first thing you'd notice, or rather not notice, is the air. Vertical bar, or the complete lack thereof. Vertical bar. Mars's atmosphere is about 100 times thinner than Earth's. Vertical bar. That's so thin it's practically a vacuum. Vertical bar. So let's say you step out of your lander for a quick selfie. Vertical bar. Before you can even say cheese, the lack of pressure would have catastrophic effects on your body. Vertical bar. Forget breathing. The air is 95% carbon dioxide anyway, so that's a non-starter. Vertical bar. The real problem is what happens to all the liquids inside you. Vertical bar. It's a phenomenon called ebulism, and trust me, it's not as fun as it sounds. Vertical bar, it's the scientific way of saying your blood would literally start to boil. Vertical bar. Now, your skin is a pretty amazing spacesuit in its own right, so you wouldn't explode like a water balloon in a microwave. Vertical bar. But the moisture on your tongue, vertical bar in your eyes, vertical bar and lining your lungs would instantly vaporize. Vertical bar. The nitrogen dissolved in your bloodstream would bubble out of solution, kind of like opening a can of soda you just shook violently. Vertical bar. These gas bubbles would block blood flow, causing immense pain and leading to a fatal embolism within seconds. Vertical bar. All of this would happen in less time than it takes to watch a TikTok. Vertical bar. You'd be conscious for maybe 15 seconds, just long enough to realize the profound cosmic mistake you just made. Vertical bar. So let's assume you're smarter than that and you stay in your suit. Vertical bar. You're safe now, right? Vertical bar. You can start doing some cool Martian science, maybe build a potato farm. Vertical bar. Well, not so fast. Vertical bar. Your suit is now the only thing keeping you alive. A fragile bubble of Earth in a sea of deadly nothingness. Vertical bar. Every seal, every joint, every layer of fabric is under constant stress. Vertical bar. The tiniest puncture, a microscopic tear from a sharp rock or a clumsy fall, becomes a death sentence. Vertical bar. That little hiss you hear isn't just air escaping. It's your life support system bleeding out into the void. Vertical bar, and the countdown to your blood boiling has just begun all over again. Vertical bar. Okay, so your suit is holding up. You've avoided instantaneous blood boiling. Congratulations, vertical bar. You've survived your first minute on Mars. Vertical bar. But the planet has plenty of other tricks up its sleeve. Vertical bar. Let's talk about the weather. Vertical bar on Mars, there's no gentle spring rain or a light dusting of snow. Vertical bar. Instead, you get planet-enveloping dust storms. Vertical bar. These aren't just a little bit of dust getting kicked up. We're talking about storms so massive, they can cover the entire planet for weeks at a time, blocking out almost all sunlight. Vertical bar. The rover's Opportunity and Spirit were both ultimately killed by these storms. Their solar panels coated in so much dust they simply couldn't recharge. Vertical bar. Now, because the atmosphere is so thin, you wouldn't feel the wind like a hurricane on Earth. Vertical bar. You wouldn't be blown off your feet. Vertical bar. The danger is far more subtle and technical. Vertical bar. That dust is composed of incredibly fine, abrasive particles like microscopic sandpaper. Vertical bar. It gets into everything. Vertical bar. It would work its way into the joints of your suit, grinding them down and compromising their integrity. Vertical bar. It would clog your air filters, forcing your life support system to work harder and harder until it fails. Vertical bar. And it would coat your helmet's visor, slowly plunging you into a terrifying claustrophobic darkness, leaving you blind in a hostile world. Vertical bar. Let's not forget about the radiation. Vertical bar Earth's thick atmosphere and magnetic field act as our planetary radiation shield, protecting us from the sun's harmful rays and cosmic radiation. Vertical bar Mars has neither of those things in any significant way. Vertical bar. Walking around on the surface of Mars is like getting a full-body CT scan over and over and over again. Vertical bar. Without substantial heavy shielding, we're talking meters of rock or soil, the constant bombardment of radiation would shred your DNA. Vertical bar leading to acute radiation sickness and a dramatically increased risk of cancer. Vertical bar. Your high-tech suit might stop the vacuum, but it can't stop those high-energy particles. Vertical bar. So let's paint the final picture. You're on Mars. Vertical bar. A tiny breach in your suit could make your blood boil. Vertical bar. The very ground you walk on is radioactive. Vertical bar. And at any moment, a planetary dust storm could roll in, blinding you, choking your equipment, and leaving you to slowly freeze in the dark as your power drains away. Vertical bar Mars gives you this glimmer of hope, this illusion that it's the next frontier, a second home. Vertical bar. But in reality, it's a cold, irradiated, vacuum-sealed tomb, just waiting for one tiny thing to go wrong. Vertical bar. It's not about if it will kill you, but how many different ways it will try first. Vertical bar. If you thought the rocky planets were bad, just you wait. We're now heading to the king of the solar system, the colossal gas giant Jupiter. This thing is a monster. It's so big that all the other planets could fit inside it. There's no surface to land on here. Your visit would be a one-way, endless fall into the abyss. Imagine dropping a super strong, futuristic space capsule into Jupiter's swirling, colorful clouds. For a moment it's beautiful, like skydiving through a celestial watercolor. Then the beauty turns to terror as pressure ramps up, really ramps up. At the cloud tops, the pressure is similar to Earth, but it increases exponentially as you fall. A capsule built like a deep-sea submarine would start to groan and creak under the strain. You'd be watching your pressure gauges spin like a slot machine, each tick closer to catastrophic implosion. Jupiter's gravity, 2.5 times that of Earth, pulls you down faster and faster. You punch through the upper ammonia clouds into savage turbulence. Inside the capsule, you're tossed violently, bone-jarring shifts and gut-wrenching drops. These are winds whipping around at over 360 kilometers per hour. And then come the storms. The Great Red Spot, a storm raging for centuries, bigger than our entire planet. It would swallow you whole, exerting forces that could tear a battleship apart. And if the pressure and the winds weren't enough, Jupiter has another feature: lightning. These are megabolts, hundreds of times more powerful than Earth's. They flash through the clouds with terrifying frequency. Your capsule would be a metal target in the middle of the universe's most intense electrical storm. A direct hit would be catastrophic, instantly frying electronics, disabling life support, maybe blasting a hole through the hull. You are falling, being crushed, and being zapped all at the same time. By some miracle, the capsule survives the lightning and the initial turbulence. You're now descending deeper into the belly of the beast. As the pressure mounts, the temperature starts to climb dramatically. You've passed the freezing ammonia clouds and entered a region of water, ice, and vapor, pressure around 10 times Earth's. It's getting hot in here. Your capsule's cooling systems are working overtime, glowing red hot on the outside. You're being slow cooked inside your own spaceship, deeper still into the hydrogen and helium heart of the planet. Pressure rises to hundreds, then thousands of times Earth's surface pressure. Around 1,000 kilometers down, hydrogen begins to behave like a liquid, a planet-sized ocean of liquid hydrogen. The forces on your capsule would be unimaginable, squeezed from all sides by pressures that can crush carbon into diamond. No known material could withstand this. Your capsule would finally, inevitably, implode. The implosion would be instantaneous and absolute. The hull would buckle and shatter in a fraction of a second, and liquid hydrogen would rush in. You would be crushed with a force equivalent to being at the bottom of an ocean thousands of miles deep. Your body would be instantaneously obliterated, compressed into a tiny, unrecognizable speck. One moment you're watching the pressure gauge scream. The next, you and your billion-dollar spacecraft are just another collection of atoms absorbed into Jupiter's interior. And what if, hypothetically, you could survive the pressure? You'd keep falling until you reach the core. Scientists theorize the core could be a dense, hot soup of rock and metallic hydrogen. Temperatures could be hotter than the surface of the sun. So your journey ends one of two ways: crushed into oblivion by the pressure, or vaporized by the heat of the core. There is no survival on Jupiter. There is no escape. There is only the fall, and then nothing. It is the ultimate cosmic dead end. Okay, if Jupiter is the king of crushing you, its neighbor Saturn is the queen of slicing and dicing you. When you think of Saturn, you think of those rings, right? They look so beautiful, so serene and elegant from a distance, like a perfect ethereal halo. But get up close, and that celestial halo turns into a celestial blender. Those rings are not solid. They are made of trillions of individual pieces of ice and rock. Tiny dust grains, mid-sized chunks as big as a mountain. And all of them are whipping around the planet at insane speeds, tens of thousands of kilometers per hour. Imagine trying to fly a spaceship through that. It's not a matter of dodging a few big asteroids. It's like flying through a cosmic sandstorm where every grain of sand is a bullet. Even a tiny speck of ice, no bigger than your fingernail, would hit your ship with the kinetic energy of a hand grenade. It would punch right through the hull, causing explosive decompression and turning the inside of your ship into a shrapnel-filled death trap. A collision with a slightly larger piece, say the size of a baseball, would be catastrophic, ripping your ship to shreds in an instant. There is no safe path through the main rings. They are a chaotic, high-speed demolition derby that has been going on for millions of years. Any attempt to navigate them would be suicide. Your ship would be shredded into confetti in seconds, its component parts joining the very ring system that destroyed it. You and your crew would be flash-frozen and shattered, your remains destined to orbit Saturn as tiny, glittering particles for the rest of eternity. It's a poetically grim fate, to become a permanent, sparkling part of the beautiful thing that just obliterated you. So let's say you're smart and you decide to avoid the rings altogether. You just want to orbit the planet from a safe distance. Well, you're still not out of the woods. Saturn's entire system is a busy place. It has over 80 moons, all with their own orbits, pulling and pushing on each other. Stray debris, rogue chunks of ice dust that didn't quite make it into the main rings. The chances of a random, high-velocity impact are still terrifyingly high. The beautiful, serene view of Saturn is a lie. The entire system is a minefield. But let's assume you've mastered orbital mechanics, dodged every single piece of ice, and you decide to take the plunge into Saturn's atmosphere, just like we did with Jupiter. Surprise! It's also a terrible idea. The first thing you'll notice are the winds. If you thought Jupiter's winds were fast, Saturn says, hold my beer. The winds at Saturn's equator can reach speeds of 1,800 kilometers per hour. That's faster than the speed of sound on Earth. Your capsule would be caught in a supersonic jet stream, ripped and torn by unbelievable shear forces as you pass through different layers of the atmosphere, moving at vastly different speeds. The turbulence would be off the charts, far exceeding anything you'd experience on Jupiter. The entire planet is racked by enormous storms. In 2010, NASA's Cassini spacecraft watched a storm erupt that was so large it eventually wrapped around the entire planet. This great white spot was a colossal electrical storm, generating lightning bolts 10,000 times more powerful than those on Earth. Again, you're a tiny metal can in a planet-sized thunderstorm. And just like on Jupiter, as you fall deeper, the pressure and temperature skyrocket. Saturn's composition is very similar, mostly hydrogen and helium. You'd pass through layers of ammonia ice-water ice, all while the pressure climbs to unbearable levels. Your capsule, already stressed to the breaking point by the supersonic winds and titanic lightning, would begin to groan under the compression. The heat from friction would be immense, turning the exterior of your craft into a glowing ember as you plummet deeper and deeper into the planet's gaseous depths. Ultimately, your fate on Saturn would be exactly the same as on Jupiter. You fall until the pressure becomes so great that your spaceship, and you inside it, are crushed into nothingness. The specific details are different. The winds are faster, the rings add that extra slice and dice threat, but the end result is the same. Obliteration. Saturn, with its beautiful iconic rings, is just a prettier death trap. It lures you in with its unparalleled beauty, and then it annihilates you with physics. It's a stark reminder that in space, the most beautiful things are often the most deadly. All right, space explorers, our next stop is a real oddball. It's the seventh planet from the sun. It spins on its side like it tripped over something in the dark and just decided to stay that way. I'm talking about Uranus. Now, before we even get to the planet itself, just arriving is a monumental feat. We're talking a journey of over 1.8 billion miles from Earth. That's like flying from New York to Los Angeles over 600,000 times. By the time you get here, you're so far from home that the sun just looks like another bright star in the sky. It's cold, it's lonely, and we're about to dive into an atmosphere that makes Antarctica look like a tropical beach resort. So, you've survived the long trip, and you start your descent. The first thing that hits you isn't a wall of heat or a crushing pressure cooker like on Venus or Jupiter. No, Uranus plays a different, more chilling game. You'd plunge into its upper atmosphere, which is mostly hydrogen-helium, but with a nasty twist: methane. This isn't the kind of natural gas that heats your home. This is a thick, toxic soup. Your suit's life support would be working overtime, scrubbing the air, but the sheer concentration of methane would be a constant, looming threat. One tiny leak, one microscopic tear in your suit, and you'd be breathing in a gas that would displace all the oxygen in your lungs in seconds. And let's talk about the temperature. We are dealing with the coldest planetary atmosphere in the entire solar system. Temperatures plummet to minus 371 degrees Fahrenheit, minus 224 degrees Celsius. That's colder than liquid nitrogen. Your state-of-the-art, multi-billion-dollar spacesuit would instantly become brittle. The materials would lose their flexibility. Every joint, every seam would be under incredible stress from the cold alone. It's like taking a rubber band, freezing it in liquid nitrogen, and then trying to stretch it. It would just shatter into a million pieces. That's your suit, and you're inside it. The initial descent would feel deceptively calm compared to the gas giants we just visited. There are no lightning storms on the scale of Jupiter, no visible surface to crash into. It's just this endless, deep, blue-green haze. But this calm is a lie. You're falling into a planet-sized deep freeze. Your body's heat would be wicked away at an astonishing rate. Your suit's heaters would be fighting a losing battle against the universe's most efficient refrigerator. You wouldn't just feel cold. You'd feel the very energy being sucked out of you, the molecular motion in your body slowing to a crawl as you sink deeper into this silent, freezing, toxic hell. So you're plunging deeper past the frigid, methane-laced cloud tops. And this is where things get really, really weird. As the atmospheric pressure starts to ramp up, something incredible happens to that methane gas we talked about. The intense pressure, thousands of times greater than on Earth, starts to squeeze the methane molecules so hard that it literally breaks them apart. It separates the hydrogen atoms from the carbon atoms. It's like taking a Lego car and stomping on it until all the individual bricks pop apart. But what happens to those carbon atoms is where this gets insane. These newly freed carbon atoms don't just float around. Under the crushing pressure, they start to bond together, forming crystalline structures. That's right, my friends, it starts to rain diamonds. Not figuratively, I mean literally. You would be caught in a downpour of solid diamonds, ranging from tiny specks to potentially massive carats, all falling through the atmosphere around you. Now that sounds kind of awesome, but these aren't the polished gems you see in a jewelry store. These are super hard, jagged crystals hurtling down at incredible speeds, turning the sky into a lethal hailstorm of the hardest substance known to science. Your capsule, which was already struggling with the cold, would now be pelted by a relentless barrage of diamonds. It would be like being inside a tin can during a hailstorm, but instead of ice, the projectiles are sharp enough to cut through steel. The view screen would scratch, then crack, then shatter. The hull of your ship would be dented, punctured, torn to shreds. The sound would be deafening. A continuous, high-pitched screaming of diamond against metal. A symphony of your own destruction played on the universe's most expensive and deadly instrument. There's no surviving this. Your ship would be methodically disassembled around you by a storm of pure carbon. And even if, by some miracle, your ship held together, the journey's end is even more bizarre. Scientists believe that deep below the clouds, Uranus doesn't have a solid rocky core like Earth. Instead, it has a strange, slushy ocean of water, ammonia, methane ices. The pressure here is millions of times that of Earth. If you reach this level, you and your ship would be compressed into something unrecognizable. The intense pressure would do to you what it did to the methane. It would break down your molecular bonds and squeeze your carbon atoms so tightly that you, yourself, would become part of the diamond rain. A tiny glittering speck falling forever into the planet's strange, slushy core. If you thought Uranus was wild, buckle up. Final planetary stop is its bigger, meaner, and windier brother, Neptune. This is the last true planet in our solar system, a deep blue giant even farther and colder than Uranus. The journey here is even more grueling, taking over a decade for our fastest probes. When you finally arrive, you're greeted by a world of impossible beauty and even more impossible violence. Neptune is famous for one thing above all else: its winds. And we're not talking about a breezy day at the beach. We are talking about the fastest, most powerful winds in the entire solar system. So let's set the scene. You begin your descent into that mesmerizing, deep azure atmosphere. Almost immediately, you'd feel it. A push, then a shove, then an unbelievably violent, unrelenting force. The winds on Neptune can reach speeds of over 1,200 miles per hour. That is faster than the speed of sound. Let me say that again. The air itself is moving at supersonic speeds. A fighter jet flying at top speed would be standing still compared to the gales on Neptune. Your capsule would be tossed around like a paper cup in a hurricane, completely at the mercy of atmospheric forces we can barely comprehend. Imagine trying to fly a kite in a tornado that's breaking the sound barrier. That's you. The sheer turbulence would be unlike anything you've ever experienced. One moment, you're being propelled sideways at 1,000 miles per hour. The next, you're slammed downwards by a downdraft moving at the speed of a bullet. The G-forces would be catastrophic. Your body would be slammed against your restraints with enough force to snap bones. Your internal organs would be sloshed around inside you, tearing away from the tissues that hold them in place. You'd black out from the G-forces long before you could even process the sheer horror of your situation. And these aren't just steady winds blowing in one direction. Neptune is a world of massive, swirling storm systems. The most famous was the Great Dark Spot, a storm system as large as the entire Earth, with winds raging at its edges. You wouldn't just be flying through wind, you'd be flying through continent-sized vortices of supersonic chaos. Your ship would be caught in these eddies and spun around violently, subjecting it to stresses far beyond its design limits. The metal would groan, twist, and start to tear apart at the seams, not from pressure or heat, but from pure, raw, kinetic violence. If by some suspension of all known physics you survive the supersonic winds, your journey into Neptune's depths has only just begun. Much like the other gas giants, as you fall deeper, the pressure and temperature begin to climb at an exponential rate. The beautiful blue clouds would give way to a dark, oppressive gloom. The weight of thousands of miles of atmosphere above you would start to squeeze your capsule like a giant, invisible fist. The pressure would build from hundreds to thousands, then to hundreds of thousands of times that of Earth's atmosphere. The interior of Neptune is a truly alien environment. Similar to Uranus, scientists theorize it has a hot, dense fluid mixture of water, methane, and ammonia ice over a rocky core. As you sink into this super-pressurized, superheated ocean, the laws of physics as we know them start to get very weird. The temperature would soar to thousands of degrees Celsius, far hotter than the surface of the sun. Your capsule, already battered by the winds, would now be simultaneously crushed and vaporized. It's the ultimate 1-2 punch, torn apart by the winds, then squeezed and melted into nothing. Let's talk about what that pressure would do to you. Forget about a suit breach. At this point, your entire ship is the weak point. The hull would begin to buckle inward, glass would powderize, and structural supports would snap like twigs. The compression would be so instantaneous and so violent that your body wouldn't even have time to register it. You and everything inside your capsule would be compacted into a space smaller than a marble in less than a microsecond. It's not a death you could feel. It's an instant erasure from existence, your atoms forced together under pressures so immense they cease to be part of you and simply become part of the planet. So as you descend into the heart of this stormy blue giant, you face a triple threat. First, the supersonic winds tear you apart. Second, the unimaginable pressure crushes you into a speck. And third, the extreme temperatures vaporize what's left. There is no scenario, no conceivable technology we can imagine that would allow for survival here. Neptune is the solar system's ultimate gatekeeper, a beautiful blue marble from afar that hides a nightmare of physics designed to ensure no visitor ever leaves. It's a one-way trip to oblivion, the most violent and definitive end to our tour of deadly planets. Alright, so after surviving, well, not surviving the gas giants, you might think a smaller, solid world like Pluto would be a welcome change of pace. I mean, it's not even technically a planet anymore, right? How bad can it really be? Well, let me tell you, this is like graduating from a shark tank to being dropped in the Arctic Ocean. The moment your boots touch the nitrogen ice surface, you're hit with a cold that is just fundamentally wrong. We're talking about temperatures that plummet to minus 375 degrees Fahrenheit, or minus 225 Celsius. This isn't your average winter chill. This is a cold so profound, so absolute, that it actively tries to steal every last joule of heat from your body with terrifying efficiency. Your state-of-the-art, multi-billion-dollar spacesuit, which you thought was the pinnacle of thermal insulation technology, suddenly feels like you're wearing a t-shirt in a blizzard. The outer layers would instantly become incredibly brittle, like glass. The cold doesn't just seep in, it invades. Within seconds, the first stage of severe frostbite would kick in on any part of your body, even remotely close to the suit's inner lining. Your fingers and toes would be the first to go, the nerve endings screaming in protest before falling silent as they freeze solid. It's a deceptive numbness that signals the permanent death of your tissue. This isn't a slow crawl to discomfort. It's an immediate, aggressive assault by the universe itself. But here's the really wild part, the science of what happens next. As the cold continues its relentless attack, your body goes into full-on panic mode. It initiates extreme vasoconstriction, which is a fancy way of saying it clamps down all the blood vessels in your arms and legs. It's a desperate survival tactic, trying to pull all the warm blood back to your core to protect your vital organs like your heart and brain. But on Pluto, this is just delaying the inevitable. You're sacrificing your limbs in a futile attempt to keep the central engine running. But the engine is in a freezer the size of a continent. Your body is making a choice you can't come back from. And while all this is happening on the inside, the outside world is just as alien and unforgiving. The air, a razor-thin atmosphere of nitrogen, methane, carbon monoxide, is completely unbreathable and would offer zero protection. The sunlight is over 1,000 times dimmer than on Earth, casting long, eerie shadows across the plains of frozen nitrogen. You'd be standing in a twilight so cold that the very ground beneath your feet is made of materials that are gases back home. It's a beautiful, terrifying, and profoundly lonely place to meet your end. A silent, frozen tomb at the edge of our solar system. So your limbs are now effectively frozen appendages, useless and dying. But the cold doesn't stop there. It's now working its way inward, past your body's desperate defenses. The next stage is systemic hypothermia, and it gets really weird really fast. As your core body temperature drops below 95 degrees Fahrenheit, or 35 Celsius, you'd start shivering uncontrollably. But in Pluto's environment, this is like trying to put out a skyscraper fire with a squirt gun. As your core temperature continues to plummet, something counterintuitive happens. Your brain, now dangerously cold, starts to malfunction. You'd become confused, disoriented, and your judgment would completely evaporate. This is where you hear stories of hikers in the cold paradoxically taking off their clothes because they feel hot. It's called paradoxical undressing, a final fatal misfire of a freezing hypothalamus. You might, in a moment of chilling delirium, think your suit is overheating and try to take off your helmet. On Pluto, that would be a very, very quick and messy end involving explosive decompression. But your brain wouldn't even know what it's doing. Let's assume your helmet stays on. The cold continues its march. Your heart rate and breathing will slow down dramatically. Your organs, one by one, will begin to fail as the water inside their cells starts to form ice crystals. These microscopic, sharp-edged crystals would shred your cells from the inside out, causing irreversible damage on a massive scale. Your kidneys would shut down. Your liver would fail. Your heart, struggling to pump thickening, sludgy blood, would beat erratically before finally giving up. It's a complete systemic and silent shutdown of every biological process that keeps you alive. And the final moment? It wouldn't be a dramatic explosion or a violent storm. It would be quiet. You'd simply lose consciousness as your brain activity ceases. Your body, now just a frozen statue in a spacesuit, would remain perfectly preserved on the surface of Pluto for potentially millions of years. A silent monument to the fact that while we can engineer our way to these incredible places, we are fundamentally fragile creatures of warmth and water. Pluto would claim you not with fire or pressure, but with the simple, absolute power of its unending cold. It's a chillingly peaceful, yet utterly brutal way to go. Okay, so let's do a quick recap of our little tour of the solar system, shall we? We sent our brave, and let's be honest, completely fictional astronaut Chase on the most dangerous road trip imaginable. First up was Venus. He was crushed, he was cooked, he was dissolved in sulfuric acid rain. Then it was off to Mercury, a fun game of don't get flash fried, or flash frozen. Mars gave us a glimmer of hope, but its thin atmosphere and dust storms reminded us hope is dangerous. Then came the big boys. Jupiter said, "Hold my beer," and shredded Chase's capsule with lightning, pressures that could crush a submarine like a soda can. Not to be outdone, Saturn threw Chase into its rings. The rings are basically nature's high-speed blender made of ice and rock. Think of it as death by a trillion tiny hypervelocity papercuts. Uranus offered a truly unique exit, getting squeezed so hard you might just turn into a diamond. And Neptune's supersonic winds basically tore Chase apart at a molecular level. So after being burned, frozen, crushed, irradiated, electrocuted, blended, and torn apart by wind, we landed on Pluto. And what did we find? A quiet, cold, and incredibly efficient death. Each planet, each world in our solar system has its own unique and terrifyingly effective method for ending life as we know it. From the inner furnaces to the outer ice worlds, it's a cosmic minefield out there. Our little blue marble, Earth, really is a special, precious lifeboat in an incredibly hostile ocean. And that brings our tour of certain death to a close. Chase has been a real trooper, metaphorically speaking, since, Chase is very, very dead. In fact, Chase has died 8 separate times in 8 spectacular ways. All in the name of science and your entertainment. It's a testament to the sheer raw power of the cosmos and a pretty solid argument for maybe just enjoying the stunning pictures we get from our robotic probes, instead of trying to go there ourselves. At least for now. We've learned that survival is not the default setting in the universe, it's the exception. Montage. All planets visited, each with a red X over it and a small skull and crossbones icon. But this is what we do, right? As humans, we're explorers. We see a big, scary do not enter sign, and our first instinct is to build a bigger, better vehicle to go see why we shouldn't enter. It's in our DNA. We've built incredible machines that have touched the sun, landed on asteroids, and peered back to the dawn of time. So the question isn't if we'll explore more, but where we'll explore next. And that's where you come in. We need to decide on the next impossible destination for our intrepid and easily replaceable explorer. We've covered our own backyard, but the universe is a pretty big place. So where should we send Chase to explore next? Should we try for a super-Earth, a rocky planet several times the size of our own, where the gravity would be so intense you wouldn't even be able to stand up? Or maybe we should visit a hot Jupiter, a gas giant orbiting so close to its star that its atmosphere is literally boiling off into space. We could even try a rogue planet, one that's been ejected from its star system and is just hurtling through the blackness of interstellar space, completely alone and unimaginably cold. The possibilities for spectacular science-based demise are practically endless. Maybe we'll ship them all the way to an exoplanet outside of our planetary corner, like one of the worlds in the TRAPPIST-1 system. Imagine the view from a planet, with 6 other worlds hanging in its sky like giant moons. But that's a story for another what if. Pulling off these incredibly complex animations and deep diving into the science behind them takes a massive amount of work from our whole team. We love making these videos, and your support is what makes it all possible. So if you enjoy these cosmic adventures and want to see more of them, please consider supporting us. You can support us on Patreon and help us send Chase to his next adventure. Every little bit helps us continue exploring the biggest questions the universe has to offer, and of course, finding new and exciting ways for Chase to meet a grisly educational end. Thank you for joining us on this wild ride across the solar system. We couldn't do it without you. So, leave your suggestions in the comments below, and we'll see where the science takes us next. It's going to be awesome. And there you have it. 8 planets, 8 gruesome ends, a complete and total sweep. We set out to see if you could survive, and the answer is a resounding, scientifically backed, absolutely not. Not even for a second. From the crushing embrace of Venus, Mars, Mercury, Jupiter, Saturn, Uranus, Neptune, Pluto. It's beautiful, it's majestic, and it will kill you in a heartbeat. It really makes you appreciate the air you're breathing and the ground that isn't actively trying to boil, freeze, or crush you. So, until next time, keep looking up. Thanks, space explorers. That was pretty violent. I give. What planet are we on? Chase is dead. Okay.